Dear students, today we are going to discuss about construction and working principle of magnetron oscillator. Magnetron oscillator produces the microwave signal from the frequency range of 1 GHz to 100 GHz, and it uses the M-type tube and also called as a cross-field device because in the cavity gap magnetic field and electric field components are perpendicular to each other, and it is mainly used in radars, industrial heating, and in microwave ovens as a microwave signal generator. Construction-wise, magnetron oscillator consists of two cylinders, inner cylinder and outer cylinder. The inner cylinder will act as a cathode and it produces the electrons. The outer cylinder will act as a anode and the inner wall of the anode consists of cavities. In this only, a microwave signals are produced. In order to produce the sustained oscillation, a critical magnetic field must be maintained between the cathode and anode. If there is no magnetic field in the region between anode and cathode, means whatever electrons are generated by the cathode will take the straight path and it will reach the anode. If the value of magnetic field is lesser, very smaller than the critical magnetic field, means the electrons will take the curved path and it will reach the anode. If the value of magnetic field is exactly equal to critical magnetic field, means the electrons which are generated by the cathode will go very near to the anode and it will be reflected by the magnetic field, and again it will come back to the cathode. This is the required condition for producing a sustained oscillation. If the magnetic field is very higher than the critical magnetic field, means the electrons will take the smaller curved path and it will come back to the cathode again without producing any oscillations. As the magnetron oscillator consists of a cathode and anode in the forms of cylinder, it is necessary to use the cylindrical coordinate system for the analysis of magnetron oscillator. Let us take B as the inner radius of the outer cylinder and A as the outer radius of the inner cylinder, and the motion of electron in the cylindrical coordinate system is given by d by dt r square d phi by dt is equal to E into Pz by m or into dr by dt, where E is the electron charge and Bz is the magnetic field density maintained in the region between anode and cathode, m is the mass of electron, r is the radius of the electron path, where omega c equal to B into E in by m, known as the cyclotron angular frequency. By integrating equation number 1 with respect to t, we can able to get equation number 2, which is r square d phi by dt is equal to omega c r square by 2 plus k constant. When you put r equal to a, which means that electron just in the outer region of the cathode, means there is no motion of electron. So we need to put, when r equal to a, we need to put d phi by dt equal to 0. Just by substituting this condition in equation number 2, we can able to get equation number 3, k equal to minus omega c a square by 2. By substituting equation number 3 into, we can able to get the expression number 4, which represents the motion of electron in cylindrical coordinate system. At r equal to b means the electron just reaches the inner wall of the anode and it returns back towards the cathode. This is the required condition for sustained oscillation. In order to get the motion of electron under sustained oscillation, it is necessary to put r equal to b. So that just by putting r equal to b in equation number 4, we will get equation number 5. The electron velocity in cylindrical coordinate system is given by equation number 6. Just by substituting equation number 5 in 6, we can able to get the expression for magnetic field required to produce the sustained oscillation. As we discussed in the beginning, the region between anode and cathode must be maintained with the cutoff magnetic field in order to produce the sustained oscillation. Then only the electron which originates from the cathode will go very near to the anode and it will come back to the cathode. Then only oscillation of microwave signals are produced. The necessary condition to produce sustained oscillation is given by Hull cutoff magnetic field, whose expression is given by 8 into capital V naught into m by E whole power 1 by 2 by 1 minus a square by b square. This field is called as Hull cutoff magnetic field. Similarly, the voltage which is applied at that point is called as Hull cutoff voltage equation.